So we have to look at what? This series where we go from n equals 1 to what? Infinity, right? And then what we got? 1 over
square root of n.
Then what?
Minus 1 over square root of n plus 1.
Very good. And you have to find whether this series converges or diverges, right?
I okay. To find at least 10 partial sum of the series.
At least 10 partial sums, okay? All right, and then we have to determine if it converges or diverges, right? So we have to do 10 partial sums, right? So tell me this. See, the first is what? The term number 1 is, this is 1, so we can write that as 1, so this will be 1, and here we get a square root of 2, right? In the second one, the first term is the same, right? Makes sense. And here we got a square root of 2. Then what we will have next? Plus 1 over square root of 2, right? Then minus 1 over square root of 3, right? And then like the third one would be this, plus we just have what? 1 over square root of 3 minus 1 over square root of 4. Oops, sorry about that. Minus 1 over square root of. Say that once again. Right. Here I know, yeah, it's halting the pattern even though we were not doing anything. Oops, not that. Even though we did not do anything wrong, right? But still, look here, I don't know what I'm pressing F1. It doesn't like it here. 1 square root of 4 is 2, but we are just leaving it. And let me see, we don't have to keep it that big, right? So likewise we can continue, right, Eric? Okay. So plus so if I wrote the sum up to the first n terms, right, then this is what this will be, right? Makes sense? Okay. So in here, this gives you the sequence of partial sums, right? Doesn't it? Okay. So if you did this, if you say opened all the parentheses, what will happen? This will cancel this, these two will cancel, these two will cancel, this will be cancelled by the predecessor, right? And then what do I get? 1 minus 1 over square root of n plus 1, right? And as n goes to infinity, where does it go? This goes to, very nice. So this series converges, and converges to what? Simply 1, right? Now in this case we have this series. What series you got? N goes from
n equal 1
to infinity, right? And then we have
n minus 1,
3n
minus 1,
minus 1, right? Whether that converges or diverges. Now remember this, even in the case of the previous series, I mean we had looked at this. See this, if I took the limit of the nth term, then I could see that that goes to 0, right? And remember why that helps, or where that helps? It helps in determining whether there is a possibility of convergence or not, right? Because if the limit of the nth term is not 0, then the series is not going to converge, right? Okay, so in this case, so the first thing to do would be what? Let's look at the limit of the nth term. Okay, where does this approach as n goes to infinity?
One.
No, look,
I mean,
it approaches as n.
1 over 3.
Beautiful, 1 over 3, right? And which is not equal to 0. So it does not converge, right? And you can always use your sum sequence feature, okay, to get a feel about these guys. Like say we added it to 100 terms, okay. This is, see, about not exactly, but about a third of 100, isn't it, right?
Yeah.
See this here? Let me just do it to 1000. Yes, closer to the, to a third of the 1000, right? Let's test the patience of this guy. Let's just do 100,000, right? I see. Okay, makes sense. All right, good. So your next question is, n is
Equal to
1 to
infinity.
infinity. Then what does it say?
Arctangent of n.
Arctan n, right?
Yeah.
Now, so first thing we will do is, remember, what does arctan do as n goes to infinity? Yeah, remember the inverse tangent has horizontal asymptotes. Remember that right here. Okay, so right, so see this here, as x goes to infinity, all right, okay, or even negative infinity, what happens? The tangent inverse x that approaches what?
Infinity.
No, look here, not infinity, look.
When x goes to infinity.
Tangent inverse 1.5, yeah, that approaches 1.5, well close to it, because remember this, see, for tangent x, remember you had tangent x has these vertical asymptotes, remember that? At where x equals pi over 2, x equals negative pi over 2, right? So when you take tangent inverse x, okay, with x restricted between with this restricted between negative pi over 2 and positive pi over 2, then the vertical asymptotes, they change to horizontal asymptote when you take the inverse, right? So what happens? The tangent inverse x, the horizontal asymptotes are pi over 2 and negative pi over 2, right? Makes sense? Okay. So what happens is, as x goes to infinity, tangent inverse of x goes to pi over 2. Or you could have, or you could do this, say if we forget these general results, we can always look at a table of values, right? Okay. All right, and so you could just go to your calculator, right? Okay, and look at a table of values. Okay, like here we go. Let's go like 10, 20. Okay. All right, and see, arctangent of this guy here, and that stabilizes near pi over 2, doesn't it, right? Makes sense? So what happens here then? The nth term in this case also does not go to 0, right? So when the nth term does not go to 0, yeah, there is no room for convergence for the series, right? So our next question is
n equals 1
to
infinity.
very nice. Then
parenthesis 1 over e to the n
e to the n, very nice,
plus 1 over n parenthesis n plus
1, right? So here in this case you see that this goes to 0, right? So there is a possibility that the series might converge, right? But we still have to check, right? Okay. Now notice this. If you look at this portion here, like this one, okay, does this look like familiar to something? It's what? See, it's 1, 1 over e plus 1 over e square plus 1 over e cube, etc., etc., right? So what kind of series is that? It's a geometric series. Very nice. Okay, so since it is geometric series and the first term is 1 over e, right, isn't it? And the common ratio is also 1 over e, isn't it, right? So that turns out to be what? 1, right? So let's see if we can easily compute the sum of the other part. Okay, all right. Okay, just a second. I have no idea whether why did I do that. Remember when I had to put it was, yeah, and you knew that I should say that, but you thought let the old man realize. Okay, and I did realize, right? So that was what, 1 over e minus 1, right? Did I do it right this time? Good. Okay, now the second one is this guy here, and are you able to relate it to something that you are used to? Yes. You think? Is that? Let me turn the recording off so that we are at ease. So we could do it exactly the way we remember this, the way we did the very first question of our office session today, that we can write this as a partial fraction of these two, right? Makes sense? So when I write the sequence of partial sums, that will be what? 1 minus 1 over 2, right? Plus 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4 plus, then plus who? This will be at the end, right? And everybody except for this and this in between will cancel, right? So this becomes what? 1 minus, oops, sorry, this guy, right? And that approaches what? 1, right? So the series will converge to what? This value plus 1, right? Am I making sense? Which equals how much? I think e over e minus 1, right? Because when we take e minus 1 as common denominator, right? Once will cancel. Oh, just a second. Yeah, right. Yeah, they will cancel, right? Okay. Okay, so we got it, right? I was just trying to like check our answer, but I think we should be okay, but it's still okay. Well, we are good. This thing is just making it into a mess, right? Okay, all right, good. Okay, give me the next one. So we have sum, yeah, n is starting from where? 2 to infinity, and then what?
And then we have 2 over n squared minus 1.
Minus 1, and they told you already is telescoping, right? Okay.
To find if the series whether converge or diverge,
right,
by expressing Sn as
partial sum
as a telescoping sum.
A telescoping sum, right? So first thing to do would be what? Take the partial fractions, right? Now, do you want me to show the details of partial fractions, or you're good at it now, right?
Yeah.
Okay, so we can just automate it, right? Okay, so here, this is how it breaks in partial fractions, right? Makes sense? So this series is going to be what? Just like that one, the very first one that you gave me, like this, right? So now we are going to write the sequence of partial sums. So we will write the nth term, okay? So let's start with 2. So first we get 2 minus 1. Then here we have 2 plus 1, right? Makes sense? And then we will get what? Next one is 3. 3 minus 1. Then we get 3 plus 1, right? Then we have 4 minus 1. We got 4 plus 1, right? 5 minus 1. 5 plus 1, and then etc, etc. This is what we have at the end, right? Which equals 1 minus what? 1 over 3, then plus 1 over what? 2 minus what? 1 over 4 plus then what? 1 over 5, right? No, not 1 over 5, sorry, 1 over 3, right? 4 minus 1 is 3, right? Minus 1 over, what's that? 5 then, right? Plus, then what you get, Eric? 1 over 4, and then minus 1 over how much? 6, right? Okay, and then it keeps on going, and at the end we get these guys, right? Are we good? So then this is, you can see 1/3 gets cancelled by this 1/3, this 1/4 will be cancelled by this 1/4, this negative 1/5 will be cancelled by 6 minus 1 that comes up, right? So who are the survivors? 1 plus what? Plus 1 over 2, right? And then eventually we will have this remaining, right? Okay, and as n goes to infinity, what will happen to that? That will go to 0, right? Doesn't it? Okay, so that will go to 0, and then then in that case, okay, let's just write so the whole thing goes to what? Tell me. 3 over 2. Do you agree?
Yeah.
Okay, that goes to 3 over 2. Okay, makes sense? So now what we got?
Sum of n equals 1.
Then
we have 3 over n times this n plus 3.
N plus 3, right? So again we have to use the telescoping series. Okay, so let's assume, well, let's just do this portion. Say this is a over n plus b over what? N plus 3, right? So we got what? We have a times n plus 3, right, over this, right, then bn over the same thing here, right? Do you agree? Okay, so you have, so if you distribute and collect the like terms, you get what? A plus b times n plus 3a. Am I correct? So if you compare the two sides, you have a plus b equals 0 and 3a equals 3. When 3a equals 3, a equals how much? 1, and b equals -1, right? But you could have seen it directly, but it's good to just do it really leisurely, right? So this is 1 minus 1 over that, right? Are we clear? So we have this, right? And that changes to that, right? So when we are writing the sequence of partial sums, what will we get? So here just it'll be a little tricky in the beginning, like we get 1 minus 1 over 4, right? Plus we get 1 over 2 minus 1 over 5. So your cancellations will start after a little while, okay? 3 minus 1 over 6, right? Then plus 1 over 4 minus 1 over 7, right? Now the first cancellation shows up, right? Okay, so 1 second. One little thing we may, I see this 1/4 cancels, then okay, right? 1 minus how much? 1 over 8, right? And then we keep on going like this, and at the end we will have that, right? So what will happen is this 1/4 will be cancelled by this 1/4, -1/5 will be cancelled by this 1/5, right? 1/3 will not be cancelled, right? But -1/6 will be cancelled by the subsequent one right here, right? Am I making sense? So what happens is that you will have 1, then who are the survivors? 1 over 2, then 1 over 3, right? And whatever rest is there is will be will go to what? 0. Let me just write it in formally. The remaining goes to 0, right? So the answer will be simply what, Eric? Excuse me. Okay, sorry. All right, 11 over 16 now. Okay, so the thing is, so I'm also feeling a little bit tired now. Okay, so I think we should be in good shape. Okay, all right. Okay.